Good morning, everybody. Welcome to a overcast, cloudy end of November Wednesday of Chem 1211 with your host, me, Dr. White. Hi, everybody. All right, important announcements. After today's lecture, somewhere around 11 or earlier, I'll send out the password for quiz number 6, and you'll have until tomorrow, I think it's 11, to take quiz number 6 and upload it as a single PDF file. All right, another thing. Next week, I'll be putting in test 2 that will be in the testing center at COD main campus in Glen Ellen. That's the only place you can take it. Now, you'll have from, I think this Tuesday until next Tuesday, end of the day, to take test number 2. Also, next week, I'll talk about the final exam, which you'll be able to take from Monday until Wednesday, 11 a.m., finished by 11 a.m., the ACS final exam. I'll talk more about it. Now, today's Wednesday. By Saturday or earlier, I will post important information, test number 2. Essentially, test number 2 will cover the whole semester. The best way to study for test number 2, which is really my final, which I'm not supposed to give a final, sort of a mini final, will be best way to study is to use your exam, or I should say test number 1, and all your quizzes as practice problems. That would be the best way to study for test number 2. Use your test number 1 and all your quizzes as your practice problems. And you can also look at the video. Now, next week, I will do Monday, Tuesday, and Wednesday. The whole week, I will do a review. And I'll go over important stuff for test 2 and the ACS final, which will help you. So be sure to either come to my Zoom meeting or watch the videos next week. And with that, there's one thing I have to admit, Dr. White made a mistake, bad Dr. White, and that is I finished grading the labs you've handed in so far and said, wait a second, we're supposed to have 14 labs and we've only done 13. And next week I don't have a lab schedule. So here's what I'm going to do. Right now, I'm going to do lab 14. And lab 14 is now on Blackboard. It's my lab. You don't use the kit. And it's a fun lab. If we were in the lab face-to-face, you'd be burning stuff, chemicals. So, hi, Brianna. Anyways, so because of my mistake, I will be doing the lab I forgot to put up today. It's now in Blackboard. We'll do something different. First, I'm going to do the lab. Then I'll finish the last chapter for this semester. And as I said, and let me reiterate, fancy word time. Today, after class, I'll be sending out the password for quiz number 6. Next week, Tuesday, till the following Tuesday, you'll be able to take test 2. The best way to study for test 2, which will cover the whole semester, is to use your quizzes and test 1 as practice problems. That will help you. It'll also help you for the final, the ACS final. All right, so what I like to do now is go through a lab I forgot to put in, and I now have it in, but it's a quick lab, and you don't have to do anything with your kit. All right, thumbs up, people. Everybody see moving electrons from shell to shell on your screen. Thank you. All right. Now, as we learned a long time ago, atoms are made up of electrons, protons, and neutrons. And the protons, neutrons are in the nucleus, and around it are the electrons in the electron cloud. And they're at specific distances. And these are called groups, and chemists call these distances from the nucleus shells. And atoms have many shells. And you might want to think of them, and it's actually more complex, but think of it as concentric spheres around the nucleus. Now, atoms usually stay in their shell. Each shell has electrons that have approximately the same amount of energy, and in each shell there's subshells where the electrons have the same amount of energy. Electrons normally do not move from shells or subshells. They stay where they are. Now, if you add energy to it by heating an atom or shining light, that's another way of adding energy. To certain atoms, what happens is the electrons are here and like here, and they go, whoop, let's go up here. We got more energy. But as soon as you lose the energy, take it away, they go back down. Boom. Well, they had this energy up here. When they go back down to their original shell, they give off energy. And that energy is in the form of different colored lights. And in this lab, you will be heating different solutions. Well, if you were face to face, I'm going to be giving you the data, different solutions of molecules in a flame of a Bunsen burner. This is called the flame test. And they have more sophisticated equipment that can identify certain metals or atoms by their flame test. And you see that all the time on CSI TV programs. Now, the fun thing is when you put a chemical in a flame test, you're moving electrons from shell to shell, which is why I call this lab moving electrons from shell to shell. And when they come down, because each cation or anion has different energies, you get different colored lights. Now, I'm not going to play it now, but I highly recommend you look at both of these YouTubes because it shows you doing that. Now, if you ever thought about it, fireworks are electrons moving from shell to shell. When the explosion happens, a lot of energy interacts with certain chemicals in the fireworks. And then as soon as that energy is over, which is very quick, the electrons come back down and you get to go, ooh, ah, and see the pretty colors. Dr. White loves fireworks. When I was a lot younger, a bunch of my friends and I used to go down to the Chicago fireworks by Lake Michigan. That's before they had messed it up with the band, with the orchestra. And it was just fun. Oh, it was fun. Crowded, but fun. And I also used to go with my family. A bunch of us would go also to the one in Evanston, which was quite nice, but the Chicago one was much better. All right. Now, in part A of this lab, you'll be testing different cations, atoms with a plus charge, but they'll have the same anion. In part B of this lab, you'll test chemicals that have the same cation, but different anions. And by doing part A and B, you'll be able to find out what really causes the colors in fireworks or the flame test. Is it the cation or the anion? I'm not going to give it away. Now, again, you're not to do this at home. Again, you're not to do this at home. But if you were in the lab, we would take a glass rod with a wire loop. It's called nichrome wire. And you'd have this plate with little cuvettes where you could put the different chemicals. And then you'd light your Bunsen burner. I teach you how to do that. And then you put the wire in the flame to get it nice and hot and clean. You stick it in the cuvette, the chemical you want, and put it in the fire. And then you repeat steps 1 through 7, actually 2 through 7, because you already got the wire loop. And if we were in the lab, you would see the sodium chloride solution is yellow, the potassium chloride is purple, copper chloride is green, barium chloride is white, ferric chloride, and this is really exciting, is white with sparkles. And finally, strontium chloride, my favorite, Dr. White loves his red. Do I like red or what? But anyways, it would be red. Now, if you own a fireplace or your parents do or friends do, you can buy chemicals or product that you put into the fireplace and it colors the fire in your fireplace. And it's really these chemicals. Now, notice here in part A, the anion is Cl minus in each one of these. The only thing that changes the first element, sodium plus, potassium plus, the calcium, copper plus 2, barium plus 2, iron plus 2, strontium plus 2. Now, in part B, you'll do the same type of flame test in the ceramic plate with the cuvettes. You'll put in the different chemicals. You'll light your Bunsen burner, clean your loop, put it in the chemical, then put it in the flame and observe the color and repeat. And in table 2, we have sodium bromide, sodium chloride, sodium iodide. In each case, the cation, Na+, is the same. The only thing that changes in table 2 is the first one is Br minus, second one is Cl minus, last one is I minus. And if you notice, they're all yellow, and that's correct. Now, to have some fun, I also set up where you make some mixtures, and you do the same type of flame test. And if we have those mixtures, we have sodium chloride and strontium, and it's a yellow red, potassium chloride, strontium, a purple red. Now, my favorite is when you mix ferric chloride and strontium chloride and you put it in a flame, you get red, but it's got these white little sparkles. And if you were in class, I'd let you also mix your favorite pair for many of the chemicals we were using. Now, to make this interesting, when we do this lab, we have some unknowns. And think of it this way. The district attorney for DuPage County needs to know the identity of these samples. And once he or she finds that out, she can convict a person of a very heinous crime. I'll let you fill in the blank for what the heinous crime is. So we've got to find it out, or you do. So compound unknown A is white with sparkles. Compound B is red. Hint, look at table 1. Hint, look at table 1. All right. Now, if you've ever seen glow-in-the-dark things, and yes, I have glow-in-the-dark things. This is not dark, so it's not glowing. And I also have glow-in-the-dark paint. Dr. White likes his chemistry. And how do you make the paint, which I created strips on a card glow, you put in, expose it, I guess, the right way, or shine on very high energy light. And in our case, we use ultraviolet lamps. And on the card, there are 3 strips, A, B, and C. And you hold the lamp for 3 seconds. That's putting in a lot of energy. And what you need to do is, A, what color are the 3 different strips of this glow-in-the-dark paint? And B, how long do they last? You time it. Well, if we're in a lab, you can't turn off the lights. No, other people are doing other things like part A and B. So what I came up with is use a brown shopping bag and you can put it in there, and it's a nice way of viewing it. And when I teach this lab, we have a supply of, I think I have Jewel shopping bags I use, not that I get any money back from Jewel. All right, so forget about the card number. I have different cards, so people have to do their own. If you were to do it, you'd find area A is red, lasts 20 seconds. Area B is blue, lasts about 2 minutes. And I tell the students, if anything's greater than 3 minutes, just put down greater than 3 minutes. And that's green. Now, your job, or what you have to hand in next week by Wednesday, is the questions for this lab and your answers. You don't have to do anything else. And that's this lab. And again, like I said, I'm sorry, I counted wrong. Part of it is this is the first time we ever used this what is it, not California, Carolina lab kit, which turned out pretty good. I was very pleased to see what everybody has done with that. And it worked out really well. A year and a half ago, 2 years ago, we used this one kit, and it was terrible. I mean, it was, I mean, it was worse than, but the Carolina kit worked well, but we only had a small amount of labs. So I included some of my own. I counted wrong, and that's why we're doing moving electrons from shell to shell. All right, any questions about the lab? And if you go to Blackboard, let's do that. You'll see there's a lab here, moving electrons. There's also quiz 6 you'll be taking later today. And I have it both as a Word document and a PDF file. All right, one more chapter to go. Remember, next week, Monday, Tuesday, and Wednesday, I will review the whole semester, which is why students do good on my test 2 and the ACS final. So, last chapter, let's get to it. All right, everybody see chapter 16, Oxidation Reduction, on your screen. Thank you, Brianna. All right, watch closely. Click. This whole chapter is not going to be on test 2, and there's only going to be 1 or 2 questions on the final. So I'm going to just turn the switch off, but I do want to cover it. Now, oxidation reduction plays an important part in our life. When rust forms, like on a car, that's called an oxidation reaction. Now, again, switches off. In chemistry, mainly inorganic, because organic chemists don't use that much. Oxidation occurs when something loses electrons. Reduction occurs when something gains electrons. Remember, switch is off. Hold on one sec. You don't know one of my well, you sort of can see, you not all of it, but one of my hobbies, big hobby, is electronics. And the switch is off. Oh, I couldn't resist. Oh no, it's bad humor, but the switch is off. All right, let's get back to work. All right, so when you have an oxidation, something loses electrons. When you have a reduction, something gains electrons. And when chemicals come together, and this is confusing, which is why I'm not going to put it on the test, and the switch is off still, we call something that's a reducing agent is what provides electrons, and the reducing agent is actually oxidized. Yep, this is a little confusing. And even I get confused once in a while by this, because in organic chemistry, we don't use this terminology very often, almost never. But anyways, if you're an inorganic chemist, and you'll see it's an important part of life, you use it a lot. And oxidizing agent accepts electrons, and that's the agent that is reduced. So the name is the opposite of what actually is happening. And a way of thinking it is the reducing agent reduces the other chemical. The oxidizing agent oxidizes the other chemical. Well, if it oxidizes the other chemical, it gets reduced. Now, to follow this, remember, switches in the opposition. Oh, I like this. I also like this click. But anyways, there's something called oxidation number. And these are numbers representing the electrons assigned to an atom in a reactant and a product of what's called the redox reaction. Redox is short for reduction oxidation reaction. And there's a whole bunch of rules for how to assign numbers to different atoms or elements. We're not going to go over that. Now, once again, identifying oxidation reduction, and here's why you use the oxidation numbers. Oxidation, loss of electrons, and here it gets a little increasing. When you have an oxidation and you lose electrons, the oxidation number increases. Reduction, you're actually gaining electrons, and because of that, the oxidation number decreases. Again, switches off. See? All right. Now, there's a way of balancing equations, but let's go to the real world. Where does this play an important role? In what we call electrochemical cells, otherwise known as batteries. And here you have a redox reaction, and you actually have separate areas for each reaction. And a special type of electrochemical cell is a voltaic cell, otherwise known as a battery. Now, if you know your battery in electronics, I do, the minus side, negative side of a battery is called the anode, and that's where oxidation occurs. The cathode is the positive end of a cell. Again, switch is still off. Click. And this is where reduction occurs because electrons are used up. That's why it's positive. Now, batteries are electrochemical, or also known as voltaic cells, and they power our everything, not everything, but in my case, my flashlights. Hold on. Oops. My flashlight, that was due to a battery. And when you turn this on like that, in the battery in here, there's a chemical reaction going on to produce the energy, electricity, to make the light. And the crudest form, if you look here, you can have a battery and you have a porous disk, and at one electrode is an anode, which is negative, and the other is positive, the cathode. It even says that. And this is a chemical reaction, but it's also a oxidation reduction, a reduction oxidation reaction, redox reaction. If you look at a car battery, you have the different metal, and the liquid in there is usually sulfuric acid solution. And this is how you have an anode, cathode, and here, similar, there's acid present, different plates, the positive and negative, and inside this battery that's in your car, you have a redox reaction. I see a question I missed. All right, Anna, let me finish this up first, and then I'll answer your question. Is that okay? Give me a thumbs up. All right, thanks. If I don't, say, don't forget my question. So your batteries are redox reactions where power is formed by the reduction oxidation reaction. The parts of the battery, you have electrons, certain things gain electrons, oxidize, lose electrons, reduce, and that's how electricity is made. And there are different types of batteries. This is an old slide because I don't have lithium ion batteries. And again, you have electrochemical cells in which energy. Now, another use of redox reactions is electroplating, where you have a metal and you can put a layer of another metal over it. And this is using redox reaction. I'm done. All right, now, let's see. Let me look at something to answer Anna's question. And I just wanted to check, and I'm right. If you look in the lecture section, I do not have a review for the final exam. Why not? Because I have the reviews for all the quizzes, and you use that also test 2, use all 6 quiz reviews and test 1, which I'm going to go over again next week. I'm going to go over the important parts. Hint, be sure you watch your come. And that's why I don't have a final exam or test 2 review, because use all the quizzes and test number 1 review to study for it. Now, what I will have is test 2 important information, which will essentially be all the important information I've used for the quizzes and test 1. And does that answer your question, Anna?
So basically the test 2 that is next week, we have to know everything what was on the quiz from 1 to 6 and test 1?
Correct.
Okay, so it's basically the same.
Everything for the whole semester.
Okay, what about like this new lesson that you are like teaching us today, and you said that it's gonna be like a few questions on the final?
All right, that's a good question. Let's go over some few
Excuse me.
things that I don't have a practice problem for. Thank you for your question. All right, let's do this. Okay, let me read it. Compound Q has a half-life of 3 days. If you have 1,600 grams of compound Q, then how many grams compound Q will you have after 9 days? In other words, it's a radioactive isotope that has a half-life of 3 days. So what do you know? Well, you're trying to find grams compound Q after 9 days. You're given the half-life, T1/2, is 3 days. Now you can learn a formula, but the type of problems I do, I keep it simple. So you start out with 1,600 grams. After 3 days, you'll have half of that, 800 grams. But you have to go to 9 days. So after another 3 days, because that's the half-life, you'll have half of this number, 400 grams. But that's 6 days, and I'm asking 9 days. So let's do it again. After 3 days, you'll have half of this number. And that's the answer, okay? That's one thing that will be on test 2 that I don't have problems for, but here it is. All right, the other thing, let me rewrite this. All right, give an example where a fission reaction is used. And the answer is no question mark. A nuclear reactor. Remember yesterday I said fission occurs in nuclear reactors. And another way a question I could ask would be, give an example of where a fusion reaction is used. And whenever I see fusion, I think of the U and I think the sun. Now I could ask, what is a key part of a fission reaction that's a big element or isotope breaking into smaller ones? What's the key element of a fusion reaction? That's two small elements coming together to form a bigger one. That's a lot of energy in both cases. And that's how I could ask the new stuff. Does that help, Anna?
Yeah, sometimes I just feel like we have questions on tests that like we didn't necessarily practice. So I just want to be prepared.
Well, that's part of my, there's not much to ask. Those are the three main questions I can ask. Given a T1/2 or half-life and a certain amount of a radioactive chemical, how much do you have after a certain time? And I just showed you how to do that. And the other two things you should know is, for examples, where do you find a fission reaction? And that's the nuclear reactor, the main place. An example, where do you find a fusion reaction? And that's the sun. And there you go. Any other questions? I might have mentioned this, but this semester I cheated a little. Cheated? Yep. On lab days, normally I only go when we're face to face. I can only go about 40 minutes. Then I've got to get into the lab because you got to get into the lab. And I've got to be out of that lab room within 2 hours, 50 minutes. And so I can only do problem sets and things like that. This semester, well, I spent more than that amount because you're doing the lab at home. So I spent a lot more face-to-face time on my video doing lecture work that I normally would be face-to-face. You know what that means? I'm done for today. Next week, I'll talk more about test 2 on Monday. By Saturday or earlier, I hope earlier, I will have important information, test 2, and I'll also have an email, or I'll include in that, about the ACS final. Both of those you have to take at the Glen Ellen COD Testing Center. And in the email, and I found it yesterday when a student asked, I'll send out the end of semester hours. The testing center in Glen Ellen is open. And with that, don't forget, hand in the lab. I think quiz 1 and 2 review is, I call test 1, but later today or tomorrow, I'll work on it. And if I don't, send me a nasty email and say, you promise. Well, I'll try. Let me put a note.
Okay, so it's basically test 1, quiz 3, 4, 5, and 6. That's
Yep,
it.
test 1. All I'm going to do is take test 1 and relabel it quiz 1 and 2.
Okay.
What I had to do this semester, normally when we're online like this, I give, in the past, I give 4 tests and a final. And they changed this semester for this online course that I could only give 2 tests, and you had to take those at COD, and the final also. And so what I did is my old tests 1, 2, and 3, and 4, I broke up into quizzes. And that's what I did. All right, anything else? Any other questions? Because I'm done for today. I'm done for the week, other than tonight I'll have my office hour from 6 to 7:15 if you need help or have any questions. Anna, you have a question before you leave?
Yeah, I have one more question about the final. So the final is gonna be literally just everything where you posted, like
Yeah, it's
all
going to be the whole semester. It's called the American Chemical Society final. It's multiple choice. I think it's 60 questions. You
Is it
have,
online?
is it what?
It's not online, it's on the paper,
No,
right?
you have to go to COD testing center to take it.
Okay, and
It's
for
a
that
time,
yeah,
let me
go ahead.
finish. It's a timed exam. Students have 55 minutes unless a student is a special needs, and then they get double time. And it's multiple choice, and it's not the best test written. But anyways, that's why I have it very small amount of points if you look at the syllabus, which I'm allowed to do. And this is something the department started a couple of years ago, number of years ago. And before that, I gave my own final, which I thought was a lot better because it wasn't all multiple choice.
Okay, so I said that we have the final review, so that's gonna be it for the final.
Well, next
we-
week, I'm going to do a review for the whole semester, and Monday, Tuesday, and Wednesday. And that will cover everything that will be on test 2 and everything that will be on the ACS final. I'll be putting out an email or announcement. Essentially, my test 2, even though it's not called that, is sort of like my mini final.
Okay, but on the test 2, it's gonna be only test 1 and quiz 1 to 6, and this couple question that
And a couple of
listed today.
questions that I just showed you on nuclear. It will cover the whole semester.
Okay, so like those
What I'll
those
do is
tests are the same.
it'll be everything. What I will do before next Monday, hopefully tomorrow, because today I teach and I got a lot of stuff on my plate to do today. But I will put out, just like I did in the quizzes, important information. And I'll say, what I'll do is I'll do the point breakdown for each quiz or test or area. Okay?
Okay, so that it's gonna be
So
like a
how many
review.
points will be on mole and mole related? How many points will be on gas problems? How many points will be on so on? Now, I will tell you, and I've already promised everybody, one, there'll be some balanced chemical equation questions. Two, there'll be the three-step mole problem from test one. Also, there'll be, as I said the other day, a Le Chatelier's problem from quiz 5. And there'll be pH stuff that's also going to be on quiz 6 today. Does that help you? And I'll put this in an announcement.
Yes, and I also saw on the Blackboard that the final, whatever that is, it's 40 points, not 15. So I don't know.
What?
Does it matter?
It's how many points?
40.
40?
Uh-huh.
I might have forgot to change it. Because I used the last time I used it. Let's see something. Opening the syllabus right now. Let me,
It was more like in my grades on the Blackboard, not in
I know,
syllabus.
hold on. When I copy from per earlier class, the syllabus or the whole Blackboard and the grading center, sometimes I forget when I have to change it. All right. And let's get this open. Actually, it should be 30. So let's do this. You can see the inner workings of so I have 40 there. Can you see that on the screen?
Yeah, it's 40, not 30.
Guess what? It's 30 now. I forgot to change it. Okay.
Okay, and I also see like my lab 6 was like uploading or something. I don't know if this is like something
What
I
I'm going to do, and that's a good
I
point you raised. What I did yesterday, and I was busy doing labs for this class and the other class I teach, by Sunday morning, I will go back and check. And you should check too. All the labs, if I haven't graded one that you submitted, send me an email. But I'm going to check myself too. And with your help, you all students, because I'll make sure everything gets graded, because the student should never be penalized for a mistake I make. Okay? Anything else? You're welcome, Brianna. And with that, I'm done for today. I'm gonna get up, stretch for a minute or two, then I'll send out the password for quiz 6. And if you need help, I'll be checking my email, and also I will be having my office hour tonight. And with that, if you don't come to my office hour, I'll see you on Monday. Also, by Sunday or earlier, I'll have quiz 6 scores posted in Blackboard. And by Sunday or earlier, I'll email out your individual points for each question on quiz 6. And on Monday, I will go through all the answers of quiz 6, but I'll cut it out of the video. And with that, I'll say, have a great rest of the weekend. If I don't see you tonight, I'll see you on Monday. Gang gesund. Goodbye. Stole that from Granny to Beverly Hillbillies. Bye.